another example. So example on signal construction. Here we have the signal diagram. This is the function of x of t. And the question here is write x of t in terms of unit step and ramp functions. Now let's see how we can do that. So first, x of t is equal to, first we have to see which function we are beginning with. And here you can see this is a unit step function, but this is in the beginning it's happening at 2. So we just put 2 in front of it and it's going up, so this is positive. And then since this is happening at 2, we put a 2 in front, and then u of t, and then we have to see how many shift. If it's shifted to the left, here we're going to have plus. If it's right, it's minus. So this shifted to the left by 2 units, so t plus 2 right here. And then minus. The next one is also a unit step function, but it's going down, so that's why we put a minus. And that is happening at -1, so 1 unit to the left. So this is going to be u of t plus 1. Okay, and it's going until this 1, and it's going down, but this is not going straight down. If it's straight down, that's a unit step function. If it's going down like a ramp, this is a ramp function. So this is, since it's going down, this is a minus ramp function, and the slope is -1, so we just put minus. And since it's going from 1 to down, you don't have to put anything in front. Okay, here also this is going down and stop at 1, that's why we just put -1 right here. Okay, so minus ramp function r, and then this is happening at 1, and this is 1 unit to the right, so this is going to be t minus 1 right here. And we can always go ahead and plug some values and check whether it's right or not. And also okay, you know what, we have to know what's happening. Like, let's say the line goes like this forever, so we can end this one like minus. Now you have to see, like, if you put a u of t, like, so this is, let's get rid of the minus. So we have to think in terms of, if I add which value that goes flat, like there's a negative slope going on. And if you put a u of t right here, because when you see flat, you may think this is a u of t, but if you put a u of t, it's going to jump up 1 unit and goes like this. So that's not what we want. We want a flat. So if this is minus 1 slope, and if I add which slope, that will make it 0, because 0 is the flat line. So we have to add a +1 slope, and then only -1 plus 1, that becomes a 0 and goes flat like this. So we have to add a ramp function, and then that should be happening at 2 units to the right. So this would be t minus 2 right here. Okay, and that's the signal construction. Now we can always verify by plugging in some values. So we can check by putting some value like x of, let's say x of 1. 1 is the time, so let's apply 1 for all the times in the function we derived. So 2 u of t plus 2, that's 1 plus 2, that is 3, and then minus u of 1 plus 1, that's 2, and then minus 1 minus 1, that's 0, and then 1 minus 2, that is -1. So here we have to know the behavior of a ramp function and unit step function. The unit step function is 0 when it's negative. It's only start 1 from positive values. So do we have any negative? Let's take care of the zeros only first. So do we have any negative values? No. So we don't have to worry about any unit step function. Let's look at the ramp function. The ramp function behavior is, when it's negative value and 0, it's 0. When it's positive value, it goes with the slope. If the slope is 1, it's 1. If the slope is 2, it's 2. Like, not slope, actually time. Goes with the time. If the time is 1, it's 1. If the time is 2, it's 2. If the time is 3, it's 3. Because its slope is 1. So it's going to go with the time. So here it's 0. So negative and 0, if the ramp is negative or 0, it's 0. So here this is 0, so this one is 0. And this is negative, this is also 0. So these two we have taken care of, and the unit step function always 1 in the positive and 0. So here instead of this u of 3 we can just put 1, 2 times 1, and then instead of u of 2 we can just put 1. So 2 times 1 is 2, minus 1, that's going to give us 1. Now let's check. At x of 1 this should be 1. At x of 1 you can see this is 1. So it means this is right. We just verified it right. Now let's try to verify another value. Let's say x of 3, and if we plug 3 for the times, what's going to happen? This is going to be 2 u of 3 plus 2, that's 5, and then minus 3 plus 1, that's 4, and then minus r, 3 minus 1, that's 2, and then plus 3 minus 2, that is 1, r of 1. Okay, let me get this one. So first we have to see if we are getting any negative value for the u of value. No, so we don't have to worry about that. And r of value, if we have negative or 0, that is 0, so we don't have anything like that. Now we can just start plugging the value. So unit step function is always 1 when it's 0 and positive values. So here u of y is going to be just 1. And then again unit step value is always 1 when it's 0 and positive value. So this was a 1. And then ramp function is 0 when it's negative and 0. But if you have a positive value, it goes with the time. Like if the time is 2, the ramp function is 2. If the time is 3, the ramp function is 3. So here the time is 2, so the ramp function is 2 right here. And then here the time is 1, so the ramp function is 1. And let's add them. 2 minus 1 minus 2 plus 1. So 2 minus 2, that's 0. Plus 1 minus 1, that's 0. So these two cancel, these two cancel. So this is 0. So at x of 3 we have to get 0. So x of 3 is right here, and here we are seeing this is 0. So that means this is also right. Therefore the answer we derived is right. Okay, and that's how we do signal construction. I hope you guys find this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.